Okay, what now starts is a series of presentations on DNSSEC. First up is it's the UK Network Operators Forum, so we have a presentation on the latest for DNSSEC signing of the .uk zone. So I'll hand you over to Ian Meikle from Nominet to talk about that.
Hi, Hi. I'm Ian Meikle from Nominet. I'm going to go a sort of overview of what we're doing about signing.uk and an update of where we are at the moment and a description of the major milestones that we've got coming up. I'm not going to give a description of DNSSEC. If you don't know about DNSSEC, you're probably in for a fairly dull hour because there's a couple of presentations following this. But basically, it's about securing DNS, as the name suggests. It's about signing resource records and including the public keys and the digital signatures and other cryptographic parameters within the zones so that DNS responses to DNS requests can be validated through a chain of trust. So what I'm going to talk about is what we're doing and why we're doing it, how we're doing it, what are we concerned about around it, and like I said, some of the timeline, when we're going to start doing what we're doing. And there'll be time for questions at the end. It's something that we have a vision at Nominet. We have a vision statement, we have a mission statement. And part of that makes it clear that we're committed to a secure internet. We've had a few internet standards, RSCs, and a BCP on DNSSEC published. We are very keen to sign.uk. We want to make it possible for the whole of .uk to be signed. .uk itself, the way we register domains, we do it at the second level. So we have the opportunity to sign a simple, small, static zone in the first instance, which is what we're doing at first, which with .uk. When it comes to the SLDs, the second level domains, we're going to have a lot more issues around signing it because we've got to make sure that we can deal with something that's changing much more rapidly, is much larger. We're going to have to implement continuous signing or find some way to sign a very large zone very quickly. We're also going to have to make sure that the registration systems change so that people can actually pass up delegation signer records to us so that we can include those in there. So there's a bit more development work. So what we're using this is a kind of learning experience to make sure that we get DNSSEC right, and then we can implement it at a much higher level. The signing architecture itself is pretty simple. We have, for the whole of UK DNS, we've got a hidden master, which is used primarily for the second level domains. It's something that we use to generate dynamic updates based on the register. But from this point of view, it's just the place where the canonical .uk zone is stored. That is then pushed out to our public name server constellation through our public master. And the signing mechanism is just a bump in the wire. We just have a signer sitting in between the hidden master and the public master. The signing itself is done using OpenDNSSEC. This comes back to what I was talking about with the vision. We have been one of the main collaborators with a few other CCTLDs and a few other individuals and companies to develop what we think is a one-stop shop for DNSSEC deployment. So it's something that's free, it's open source, we encourage people to use it. And it consists of several modules, several parts. There's a unit of OpenDNSSEC which actually signs the zone, and then there's another part of DNSSEC which checks that, which audits the zone to make sure that it's been signed correctly. So it's kind of a safety check, a safety harness on the zone signing, because once you've done it, it's very hard to undo the signing. These two were written by different programmers using different languages and different libraries so that it's meant to be as independent as possible. And it's actually worked as a kind of quality control whilst the code's being developed, because one finds bugs in the other. But from our point of view, the main reason for using for OpenDNSSEC is the key management. There's several different keys within DNSSEC. You have a key that you sign the zone with, the zone signing key, and then you have a key that you sign that key with, the key signing key, and they have different security parameters around them. They expire. They only have limited lifetime, so that they're proof against people compromising them. But because DNS itself has an idea of resource records expiring, you have to make sure that when when you publish a signed resource record, and that's cached by somebody's caching resolver, you don't expire the key too soon before the resolver has had time to expire out the signed resource record. And OpenDNSSEC does that, looks after that for you, so it makes sure that keys overlap for the required time. We have quite a sophisticated key and signing policy, which would probably make a presentation itself. I'm not quite sure this is the right audience for it, but some of the main parameters we picked out is that we have a key signing key, as I say, which is much bigger than the zone signing key and has a much longer lifetime as a result of that. The zone signing key itself lasts for 6 months. The signatures, when we sign records, last for 2 weeks, but we re-sign the zone daily. These parameters were decided mainly on industry best practice and what our hardware itself would support. So, for instance, the key signing key can be 1024, 2048, or 3096 bits, but our hardware would only support 2048, so that's the maximum that we've gone to. The sign is very simple. It's just a mid-range server running Linux. Most of the work is done by what we call a hardware security module, which is a PCI card which is installed into the box itself. That's basically just a crypto accelerator. So it's something that a lot of people use for offloading SSL work from web servers. We use it primarily as a key store. The reason we chose the SCA 6000, which is a card from Sun, is that it's relatively low cost. They're less than £1,000, and it's compliant to the level of security that we wanted, which is FIPS 140-2 level 3. This particular FIPS standard is about exactly these kind of things, about storing cryptographic parameters. But level 3 is the second highest level of security you can get on there. So what that means is, if somebody were to try and tamper with this and try to remove it from the box, or actually physically tamper with the device itself, it would automatically zero any critical security parameters that are on there. There is a level 4, which I think zeros it if it detects that somebody's walked too close to it, but it's much more secure. It's something that we would risk losing security parameters if we were to use that. We have, obviously we're running .uk, and it's an essential part of the UK internet. So we wanted to make sure that we were able to, once we've signed the zone, make sure that we could do that continually. So we had a lot of issues around, a lot of thinking around what we would do in terms of making it as resilient as possible. So we decided to make sure we had multiply redundant systems. So we've actually got 2 signers in our data centre in Oxford, one of which is what we call the leading, it possesses what we call the leading HSM. They're all identical, these signing boxes. We have another off-site signing box at our DR site. What we do is we pre-generated keys on the HSM, or we will have pre-generated keys. We're generating enough keys to last for 200 years. It doesn't matter if we don't use them, we can always throw them away if we roll the hardware security module itself, but we want to make sure that once we've got them on there, we've got enough to keep going for as long as possible, at least till it's no longer my concern. Those keys are generated on the HSM, which is in the main signing box. They're then exported onto a USB card directly, and then that HSM itself is locked against export to make sure that nobody else can actually grab those keys off there. They then transferred to the HSMs and the other signing boxes. Then again, they're locked against export. And then we've just as a sort of final belt and braces approach, we make sure that we've got the exported keys on the USB stick. Now that is a little bit of a worry, because obviously then you've got them on the USB stick, people can get hold of them. So what we wanted to do was make sure that that was secure from a data point of view. So we commissioned a company called FirstBase to do a kind of security audit on the process that we were looking at, and they came up with several recommendations. First of all, they said, well, make sure that the USB sticks are encrypted. So we bought sticks that have got encryption, onboard encryption on there. It makes sense, really, of course, that you don't want to leave this on a train or anything like that. They also said, make sure that you lock them away. And we were going to do that. We've got a fire safe in our Oxford data centre. We've got a fire safe down in the DR site. They said that it'd be good to have a third copy as well, just in case either of those were compromised. I sometimes think that when you employ a security consultant like that, they have to tell you something else besides what you're actually doing. So, but the one thing that they recommended was to keep it off-site in an independent location. So we're putting it in effectively a safety deposit box at a secret location. They also wanted to make sure that there's a separation between those who had the ability to pull the keys off the USB stick and those who had the ability to actually get the USB keys back from storage. So we've got separate access and operator roles. So it's effectively somebody outside of the technical department has the access to the encrypted USB stick. They can then pass it on to somebody who can actually get the data off. And of course we make sure we've got duplication of those roles just in case somebody falls under a bus. The other things that they came up with were the things which are very worthy and things that we were thinking of doing anyway, which is things like change management and making sure you've got regular testing. In terms of timelines, we've always wanted to do this. Like I said, it's part of our vision, was something we've committed to. We've always been a little bit wary about doing it as well. Once we'd heard that the route was going to be signed, we intended to do this around this time, around early 2010. Things at Nominet have been a little, I don't want to say fraught or drawn, but we have had obviously a lot of issues around governance lately, as I'm sure you're aware. And that has been the main focus of the business and will be the main focus of the business until we get the EGM out of the way at the end of February, sorry. So we've tried to make sure that we fit in with that kind of timescale. So on the 1st of March, we're going to start putting DNSSEC info into the .uk zone. We're going to do something quite similar to what ICANN and VeriSign are doing and put blurred keys into the zone, the equivalent of the DURZ, the DURZ keys that are going into the route. What we want to do about that is we don't want to put a key out there which is only meant to be a kind of temporary key just to do a kind of feasibility study and then find that somebody else has taken that, so that's Nominet's key. And then when we put the live keys out there, it breaks. We're also running for the first week just on selected name servers. The way we advertise DNS is we have a set of name servers that are hosted by, managed by Nominet and a set that are hosted by a third-party Anycast provider. For the first week, we're going to be running it on the ones that we manage ourselves, or on a subset of those. We're going to be making sure that we're sampling the traffic that comes to them. We do keep running PCAP logs of all the data that comes onto all the queries and responses that come through our name servers. So we'll have sort of a forensic tool, but we're also going to be watching the query rates and seeing if we can detect any sort of noticeable shifts which indicate that either people are preferring the DNSSEC signed name servers or are rejecting them for whatever reason, so that we can then make a decision to whether to go or not on the 8th of March. Presuming that everything works in that week, we're going to start signing the zone itself, and we're going to be putting valid keys and signatures into the .uk zone on all of the .uk name servers. But we're not going to actually publish our key information anywhere else. We're going to have what we call a period of extended operational testing until such time as IANA will allow us to put the .uk delegation signer resource record into the route. Any questions? Yes.
Yeah, Gavin Brown, Central Nick. My question was, why aren't you using the ITAR? Is it just because there's just not much, there's only a few months to wait?
It's partly because there's a few months to wait, but it's also we want to make sure that we don't start putting things in different places and then have to update delegation signers in various other
well, yeah, I mean,
countries.
yeah, okay, understood. Just for the benefit of people listening, ITAR is the interim trust anchor repository that IANA is running for those TLDs that are signed before the root sign itself is signed.
Keith?
When you were looking at secure USB sticks, did you consider the Iron Key product?
It is the Iron Key that we're going to
You're
use.
going to use that, right?
Okay. Thank you very much.
Okay, so the next speaker is me. And I'm basically switching hats from UK and off chair to my day job of Director of Engineering at Internet Systems Consortium. So what I'm going to be talking about is the plans for signing the root with DNSSEC. So there's some general stuff in there which will probably overlap with the next speaker. But more importantly, some of the specific things that we're doing at ISC in support of froot, which is one of the 13 root name server instances that we operate, and also the bind software that we produce that goes behind that. So I'm not going to give you the DNSSEC tutorial. DNSSEC has been around for many, many years. And basically, what does it let you do? It means that when you get a response to a DNS query, you